Next, we're going to look at two special classes of functions, even functions and odd functions. So even and odd functions are two special classes of functions that have a particular symmetry. So first of all, let's write their definition. So a function f is even if f of minus x is equal to f of x for all x. And then a function f is odd if f of minus x is equal to minus f of x for all x. So first of all, a function can be neither even nor odd, right? So this is not an exclusive group where every function must be even or odd. Like every integer has to be either even or odd. In this case, there could be functions that are even, functions that are odd, and functions that are neither even nor odd. So even and odd functions have specific types of symmetry. So if we look at the definition of even function first, so let's just look at even functions. So here we said f of minus x was equal to f of x. Now we know from the previous video that f of minus x represents a reflection. So this is a horizontal reflection about so it's a reflection about the y-axis. And so basically what this equation says is that if you reflect the graph of the function f about the y-axis, you get the same graph, right? So the original graph of f of x has to equal the graph of the reflection. So let's take a look at what that might look like. So here's the x-axis, there's the y-axis. That's an example of an even function, right? Because if I reflect it about the y-axis, I get the same thing. A second way to look at that is to think of this definition as a prescription for how to generate the outputs for the negative x values. So for example, say I have minus 1, minus 2, minus 3, and then I have 1, 2, 3. If I want to compute f of minus 1, if it's an even function, f of minus 1 has to equal f of 1, right? So the output at minus 1 has to match up, so this is supposed to match up, the output at 1. Similarly, the output at 2, or minus 2, has to equal the output at plus 2. So that does, ignore the imperfections in my drawing, but you think you see the point. And the output at minus 3 has to match with the output at plus 3. Right? So basically there's a symmetry. It's a mirror image about the y-axis, and that's what an even function is. So let's say you were asked to show that f of x is equal to e to the minus ax squared is an even function. And here a is just a constant. So to do that, what we do is we would say, well, let's compute f of minus x. So f of minus x is equal to e to the minus a minus x squared is equal to e to the minus a. Now minus x squared, minus x being in the parentheses, is just equal to x squared, which is equal to f of x. So that would prove that it's an even function. So next, let's look at odd functions. So here we have f of minus x is equal to minus f of x. So what we have now is that if you reflect it horizontally, you get the same thing as if you reflect it vertically. So let's see if that's correct. So let's say I start with, so here's an example of an even function. Yeah, so something like this. If I reflect it horizontally, so if I look at f of minus x, that's a horizontal reflection. So that's f of minus x. I reflected it about the y-axis. On the other hand, if I flip it vertically, so if I flip the thing vertically, so if I take this guy and move it up here and reflect it, so this guy is moving down here, this guy's moving up there, and so forth, that would be minus f of x. So basically, a horizontal reflection is equal to a vertical reflection. Another way to think of this, let me draw a new graph. There's a nice odd function. Y, this is y is equal to f of x. So again, 1, 2, 3, 1, 2, 3. You can think of this as a prescription for generating the outputs for the negative x values. So if you want to know f of minus 3, it should equal negative f of 3. So f of 3 has this height, right? That's f of 3. So negative f of 3 is going to be about down here, so that's negative f of 3. So f of negative 3, the output has to equal, so this is f of negative 3. So this y value down here is f of minus 3. So this y value has to be equal to negative of f of 3. So the height here is the opposite of the height down here. So it always has this general type of shape like that. So those are even and odd functions.